So we're not doing anything new. We're going to be solving systems. But what is difficult here is you need to be able to read the real world situation and be able to create a system, right? So we're going to be able to, we need to be able to write two equations based off of what we're reading here. Okay, so obviously on this first one, somebody's selling vegetables at a stand, and they're selling two specific things, pumpkins and squashes. Pumpkins are $6 each, squashes are $4 each. And it says that on a certain day they sold 7 more squashes than pumpkins, and their sales totaled $228. Okay, so let's first start out by jotting down some notes. We're going to have to write two equations. One equation is going to be based on money. Okay, so the other equation is going to be based on the number of fruits, right? And this is mostly the case. Whenever you have a word problem that deals with money, it's most likely you're going to have to create an equation based on money, all right? So let's make an equation based on money. What do we know about money on this first problem?
Each pumpkin is $6 and this
Okay.
squash is $4.
So let's write that down. Let's write 6 times each pumpkin. What letter would be good for pumpkin? P, all right. 6 times P, because that's $6 each pumpkin, right? So like if you sold 10 pumpkins, that'd be $60, right? Okay, how about the squash?
$4 for each.
So $4 for each squash. I'm going to put S for squash. And so, I mean, in other words, if I sold 10 squashes, that'd be $40 because 4 times 10 is 40. And how much is the actual total?
$228.
So that's $228. Ladies and gentlemen, that is an equation based on money. And I hope everybody could read all these problems that have money in it and create an equation based on money. $6 for each pumpkin, $4 for each squash, total of $228. Okay, now let's make an equation based on the number of items sold here. Okay, so do we know how many pumpkins were sold? No. Do we know how many squash were sold?
Yeah.
How many squash were sold?
7 more than.
Let me go back to it. Okay, so it says right here they sold 7 more squash than pumpkins. What does that really mean? Let's think about that for a while. So like let's say you sold 10 pumpkins. How much squash did you sell? 17. What if you sold 50 pumpkins? 57 squash, right? Okay, so we don't really know how many pumpkins were sold, and we don't know how many squash were sold, but we do know that squash was 7 more than pumpkins. So let's write that down. Squash, let's put S, equals 7 more than pumpkins. How am I going to write that? 7 more than pumpkins. P plus 7. P plus 7. 7 more than pumpkins. Remember, less than, more than, you switch the order, right? So anyway, these are the two equations. One was based on money. One was based on the number. So we have right here a system that we need to solve. What method would be best to solve the system? Substitution. We have S equals P plus 7. So let's take that P plus 7 and put it into the top equation right into the S. I guess I didn't have to do that. I could have just done this right there into the S. So let's rewrite that top equation. So I have 6P plus 4S, but instead of S, what am I putting? P plus 7 equals 228. Okay, so now let's solve this simple, well, not simple, but multi-step single variable equation. So 4 times P is 4P. 4 times 7 is 28. Let's bring down the plus and the 6P, bring down the equals and the 28. After distributive property, we have combining like terms.
It's 228.
228. Oh, thank you very much. Sorry about that. See, when you go too fast, you make mistakes. Even me. Let's combine like terms here. 6P plus 4P, that's a total of 10 P's, plus 28 equals 228. So how do I start solving this red equation right here? Subtract 28 on both sides. So we're going to go minus 28, minus 28. Let me rewrite my equation up here on the side. So I have now 10p equals 200. So to solve this, I need to get rid of the multiplication of 10 by dividing by 10, dividing by 10. So p equals 20. What did we just find here? How many pumpkins we sold, right? 20 pumpkins. Is it asking for how many pumpkins were sold?
No.
It says both how many pumpkins and squash. Well, it says squash. Sorry, typo. Should be an S right there, squash. So we know how many pumpkins. We still need the squash. How do we figure that other one out? Plug it in. So right here it says the squash is really going to be 7 more than the pumpkins. So yeah, squash is going to be 7 more than the pumpkin. So yes, the squash is 27. And those are your two answers. And of course, on these word problems, you should write out your answer in words. You should say 27 squash were sold and 20 pumpkins were sold, right? But for the sake of making this video shorter, I'm just going to leave it like that. But please write it out in a sentence. All right, let's jump to number 2. Do we have money involved on this one? No. What do we have involved here? What are the two factors? Points and baskets. Points and baskets. So we're obviously going to have to create two different types of equations. One equation based on points and one equation based on baskets. Okay, since we identified that we're dealing with points and baskets here. And to make things a little more understandable, let's label, let's let the X's be the 2-pointers, and let's make the Y's be the 3-pointers. Okay, you don't have to do this, but I'm doing this. I'm putting X's to be 2-pointers and Y's to be 3-pointers. So let's make an equation based on points. So do we know how many points she scored? 42. It says right there. She scored 42. Okay, so I don't know yet how many 2-pointers she did. I don't know how many 3-pointers she did, but I do know that the amount of points is a total of 42. Now, here's the interesting part. Since we're dealing with points, I need to put the point value right here in front of X. How much is a point value in front of X? 2. So let's put a 2X instead of an X. And the Y's, how many points is the 3-pointer? 3. So let's put a 3Y. And let me pause right there and see if this really makes sense to you guys. So if she makes 10 2-pointers, right? X's represent 2-pointers. So if she makes 10 2-pointers, that's saying that she made 20 points, right? If she made 3 3-pointers, that means she made 9 points, right? Since we're making an equation based on points, you have to put the point value on each. Maybe I should have started that way. I'm sorry. But anyway, it's 2 points for each 2-pointer, 3 points for each 3-pointer, and we know that's a total, when you add them, it's a total of 42 points. Okay, now for the baskets. X represents the number of 2-pointers. Y represents the number of 3-pointers. And if we add those two together, how many baskets did she make? 17. That's what it says up here. She makes 17 baskets. Okay, so that is our system of equations. So we don't have money involved. When we do have money, then you would say, oh, 5 cents for each nickel, 10 cents for each dime, or whatever the case is. But right here, we're talking about points. So making an equation on points is 2 points for each 2-pointer, 3 points for each 3-pointer, and we're talking about total points here. An equation based on baskets is you don't know how many 2-pointers, you don't know how many 3-pointers, but you know if you add them together, it's a total of 17 baskets. And now let's solve this system right here. What would you like to do? I would multiply the bottom equation by -2. So let's multiply the bottom equation by -2. You don't have to put the multiplication on a -2 on this side. You can put it on this side just so you can know how you get this new equation down here. So the new equation is going to be -2x minus 2y equals -34. When I multiply 17 times -2 is -34. Top equation is going to stay the same. 2x plus 3y equals 42. And now we're ready to combine the lines with linear combinations in order to get the x's to eliminate. So the x's really do eliminate. We end up with 1y, and that's just y. You don't even need to put the 1. And 42, take away 34, use a calculator to be safe, is 8. So we have 1y equals 8. So what does that mean? Y equals 8. That means that she scored 8 3-pointers, right? Because y is a 3-pointers. Okay. Are they asking for 3-pointers? Are they asking for 2-pointers? Or are they asking for both? It says only 2-pointers, right? How many 2-pointers did she make? All right, so if she made 8 3-pointers, how are we going to find out? You're going to distribute? Well, you're going to plug it back in, substitute it, right? So you're going to plug in 8 right into here. So let's put x plus 8 equals 17. So we're going to subtract 8, and we'll get x equaling, what is that, 9? So she made 9 2-pointers and 8 3-pointers. But of course, the only thing they asked for is a 2-pointer, so we're going to just say 9 right there. And this is the final answer. X equals 9. Yeah.
How'd you know that?
So 9 2-pointers is the correct answer. All right. Number 3, coins. Pepito has a jar of nickels and dimes. He has a total of 65 coins, which are nickels and dimes, with a total value of $5.45. So what are we dealing with on this problem? Coins, okay? Nickels and dimes. All right, so let's make an equation based on the number of coins. And then let's make another equation based on money. So, number of coins. Do I know how many nickels? No. Do I know how many dimes? But I know that together it's how many coins? 65? So ladies and gentlemen, there's my equation based on the number of coins, right? So I don't know how many nickels, I don't know how many dimes, but when I add them together, I know it's a total of 65 coins. Now let's go for an equation based on specific money, like actual cash value here. How much is a nickel? 5 what? 5 cents. So I need to type in, or I need to put in 0.05, that's 5 cents. But I need to multiply that 0.05 by however many nickels I have. So I want to put 0.05 times n. And that makes total sense because if you have 100 nickels, then you could multiply 0.05 times 100, right? To get your value. How about for the dimes? How much is each dime worth? Plus 0.10 times d. And the total value of his piggy bank, how much is it? $5 and what? 45 cents. Ladies and gentlemen, this is our system that we need to solve. Now, a lot of people get freaked out with these decimals. We could get rid of them by simply multiplying that whole bottom equation by 100. So if we multiply by 100, let me just put in a little cloud, that's going to change it all by moving all decimal places over 2 places. So this decimal goes over here and it becomes regular 5n. This one goes over 2 places, becomes 10d. This 5.45 becomes 545 if we move everything 2 spaces over by multiplying by 100. So we're going to have 5n plus 10d equals 545. Top equation, what could I do to that top equation to get either n's or d's to cancel? Multiply it by -5?
Can't you divide the bottom by 5?
We could, if we wanted to, we could divide the bottom equation by 5 to make it a little easier. But let's not confuse anybody. Let's just go with it. Let's change that top equation to a -5n so it could cancel out with the positive 5n. So when I multiply by -5, that'll give us a -5n, a -5d, and here's the tricky one, 65 times -5. Calculator's good. -325. And now we're going to combine the lines, eliminate the ends. -5d plus 10d, that's 5d. And then 545 take away 325, or -325 plus 545. Either way on the calculator, it'll give you positive 220. So our final step here would be to divide by 5, 220 divided by 5 on a calculator is 44. D is 44. What does that mean?
Dimes,
44 dimes, right? Are they asking for that? No. They're asking for how many nickels? Yeah, so you're just going to plug it back in, and of course you could just do it in your head, subtract 44 with 65 or from 65. But anyways, I want to actually show my work here. I'm going to go to the top equation, n plus d equals 65. So the number of nickels, n, plus the number of dimes, but of course I know it's 44 dimes, it has to equal a total of 65. So if you go 65, take away 44, we end up with n being 21. So they are not asking for dimes, even though there are 44 dimes, but they are asking for nickels. So the answer number 3 is Pepito has 21 nickels. Let's move on. Illegal sales at school. Juanito.
they would use one.
No, not Juan, it's Juanito. He sells Flaming Hot Cheetos for $1.
That's illegal?
He sells Takis for 75 cents
That's illegal.
during class time and at lunch. So in one day, Juanito sold 30 bags and made a total of $26.75. How many bags of Takis did he sell that day? Well, we need to create two equations. So what are we dealing with here? We're dealing with money for sure. Okay, so we're going to have to make an equation based on money. But we're going to have to create an equation based on the number of bags. Number of bags. Okay, so we don't know how many Cheeto bags were sold. We don't know how many Takis bags were sold, but we know that together, how many were sold?
A total of 30.
30 bags. Okay, now let's make the other equation based on money. Stop it. All right. How much were the Cheeto bags? $1. So that one's easy. 1C. How much were the Taki bags? 75 cents. So plus 0.75 with the T equals the grand total that he made. How much did he make? Money. Money-wise. 26.75. Okay, so this bottom equation is based purely on money. So that's our system. One equation based on the number of bags. You don't know how many Cheetos, you don't know how many Takis, but you know it's a total of 30 bags. The other one's based on money. $1 for each Cheeto, 75 cents for each Taki, giving you a grand total of $26.75. So we need to manipulate the system and get something to cancel. Let's cancel out C's, right? Some people say, I want to get rid of the decimals. I want to multiply everything by 100. But look, you already have a positive C and a positive C. All you have to do is change one of them to be a negative. I want to do that to the bottom equation. I want to take that bottom equation, I want to multiply it by -1. So the top equation is going to stay exactly the same. It's going to say C plus T equals 30. And the bottom one's going to change to -C minus 0.75T equaling -26.75. And now that we've modified it, it's ready to do linear combinations to eliminate the C's, the Cheetos. So even if you don't know decimals, you could use use a calculator. You have one whole right here, take away 0.75. What's one whole, take away 0.75? 0.25. So we have 0.25 of these T's equaling, and with the calculator, 30 take away $26.75. That's 3.25. So we need to solve for T, and it really has the multiplication of 0.25 in front of it. So let's get rid of that 0.25 by dividing by 0.25 and dividing by 0.25. With the calculator, take 3.25 divided by 0.25 and you will get 13. So T equals 13. So we know that there's 13 bags of Takis sold on that day. Are they asking for Takis?
Yep.
Yeah.
Yep. That's it. We're done. Now, if they ask for Cheetos, you'd have to take the Takis bag, plug it back in, or Takis value of 13, plug it back in right here, and then solve for C. But we don't have to do that. We already answered the question. All right, last problem here. Museum field trip. A group of second graders are going on a field trip. An adult ticket costs $6 and a child ticket costs $4. There were 32 tickets purchased
Adult and child tickets.
of adult and child tickets, and the total cost was $184. So we need to make two equations. One's going to be based on what? Money. Okay, and the other equation is going to be based on number of tickets. Okay, so let's talk about number of tickets. Do we know how many adults went in there?
No.
No. Do we know how many children tickets?
Second grade.
We don't know. Second graders. All right. So together, how many tickets were sold? 32 tickets. Ladies and gentlemen, that is an equation based on the number of tickets. Right? Number of tickets, there's an equation. You don't know how many adults, you don't know how many children, but you know it was a total of 32 tickets. Now let's make one based on, I'm not going to say it, just money. So how much is each adult ticket? $6. So 6 times each of those A's. How about the child ticket? 4 times each of those child tickets. And how much money did they actually spend? 184. That's what it says, total cost of 184. So this is our system that we created. That's the hard part, guys. Once you create the system, it's all about solving either with elimination method, substitution, or whatever you feel more comfortable with. So let's solve this thing. What would you like to do? Cancel out A's or C's? Cancel out A's? Especially because they're asking for how many children went, right? So let's cancel out A's by multiplying that top equation by -6. So when I multiply by -6, it's going to be -6A minus 6C equaling, let me figure that out. 32 times -6 with the calculator is -192. The bottom equation we're going to leave the same. Positive 6A plus 4C equals 184. So now we're ready to combine the lines, eliminate the adult tickets, and we're going to have -2 children tickets, and that's kind of weird, negative children tickets, right? But when I go -192 plus 184 on a calculator, I get -8, and that's great because when I divide by -2 here, it'll take me back to positives, which makes more sense. +4. So how many children's tickets were sold? 4. Which makes this a really weird field trip. There was all kinds of parents and only 4
What happened was
four
there was
kids.
4 kids, and then each kid had 4 parents.
4 parents, right? Step parents, and then several step parents, maybe grandparents, right? Okay, well anyways, they're asking for how many children went. 4. You don't have to find out how many adults. If you did want to find out how many adults, you simply take the 4, plug it back in, find out how many adults, right? Okay, I'm done. This is a section on word problems, and we will have some of these exact questions on our homework and some of these exact questions on our test on Monday, a week from today.